Part A is asking, is the particle speeding up or slowing down? Now think about what it is that we need to know, and this is at time 4. What is it that we need to know to determine whether the particle is speeding up or slowing down? So that would mean we need to know V of 4, and we also need to know A of 4. Okay, now remember that this is a calculator question. So you can put this value in your Y1, and then just go to either your table and look at your values. But your table of values isn't going to go out far enough. I don't think it's going to go out 4 decimal places. So what I like to do is go to the home screen and then just do vars, y vars, enter, enter. And then what you're going to see when you do that is you'll just see your Y1 there like that. And then you'll open a set of parentheses and put a 4 in there and see what you get. Okay, so when you do that, you should get 2.9787, and that you're not going to see in your table of values in the calculator. That's why I prefer to do this instead. Okay, now A of 4. Now let's think about what is the relationship between A and V. And remember that A is the derivative of V. Now your calculator will not give you the derivative, but it will give you the derivative at this particular value. So home screen, and go to Math 8, and then put in x in the denominator with the d, then do vars, y vars, enter, enter, and then put in x equals 4 and see what you get. Okay, pause me and figure that out. Okay, so I have negative 1.1640. All right, now let's look at the conclusion that we should make based upon these two answers. Look at these two answers. What is it that's going to determine whether we're speeding up or slowing down? And you should remember that if the signs are opposite, right, so we have opposite signs there in the velocity and the acceleration at time 4. So therefore, the particle is slowing down. Okay, the particle would be speeding up if both the signs were the same. If V of 4 and A of 4 were both positive, or if they were both negative, then the particle would be speeding up. Part B is asking, when does the particle change direction? Now think about that. A particle is going to change direction when? Remember, we're going to look for the velocity, and we're going to look for sign changes. Now, the easiest way to do this is, well, we've got an equation of the velocity. It should already be in your Y1, and this is a calculator question. So for me, I think the easiest thing to do would just be to draw a picture. So if you put that in and get yourself a graph, this is roughly what your V of t is going to look like. And right here at this point, we can see that there is a sign change. So here the velocity is positive, and then after this point the velocity is negative. So what we need to do is find that point. So why don't you pause me and do second calc 0 and see what you end up getting. Okay, I have t equals 2.7074. So now listen, if you're a sign chart person, not that it's necessary, but you certainly can. Your sign chart would be 2.7074, and we'd have a plus here and a minus here. So you can see that there's a direction change. Okay, and then in part B, it says find all the times between 0 and 3. So just remember, we're looking for the times that are between 0 and 3. So then your answer would be t equals 2.7074. And you would say because the velocity changes sign about this point. And I'm going to abbreviate about this point. You don't have to say how it changes. As long as you have this picture, you can see that it goes from positive to negative. You can put that in your explanation. That's totally fine, but it's not necessary. Okay, we're going to skip part C and part D because for what you need to know for the AP for this year, you don't need to know that.